So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. I hope you guys are doing fine. Welcome back to another physics lecture. Today we are going to start section 4.3 electrical circuits. An electric circuit is a collection of electrical devices which are called electrical elements or electrical components, which are connected together by conductors or wires in a closed path. Circuit elements include sources of electrical energy such as a battery or a cell, sinks of electrical energy such as light bulbs, and switch to complete or break the circuit. Conductors, for example, copper wires, are used to connect them together. Now for drawing out electrical circuits, we need to have a list of electrical symbols. These are the essential part for the study of current electricity, and they are often drawn symbolically. In circuit diagrams, various circuit elements are represented by standard symbols. These are the symbols that you are supposed to know from your syllabus. This is a single cell, this is a battery of cells which can be drawn like this as well. This is a power supply, this is a DC power supply, this is an AC power supply with a little sine wave in between. This is the symbol for a fixed resistor, this is a variable resistor which has an arrow on it. This is a switch, this is a earth symbol. If two lines are crossing each other with a dot in between, it means a junction. This is the symbol for a lamp, this is the symbol of a motor, this is the symbol for a generator, and this is an ammeter. Next we have thermistor, light dependent resistor, a heater, a potential divider, a transformer, a magnetizing coil, a voltmeter, a diode, a light emitting diode, a fuse, a relay coil, and an oscilloscope. Circuit diagrams. A simple circuit with a cell or a series of cells and a resistor or a bulb. An ammeter is used to measure the current flowing through the circuit and must be inserted in series, whereas a voltmeter is placed in parallel in order to measure the potential difference between 2 points or across a single component. Now some of these symbols you have already seen so far. Some of them we have not discussed and they will come up in later sections. so don't worry about them at this stage. Just make sure that you know or learn all of these symbols. An ideal ammeter has zero resistance so that all of the current flows through it and it does not slow down any of the current that passes through it. An ideal voltmeter has finite resistance so that it takes no current at all. A finite resistance would cause it to take the current from circuit and lower the potential difference between the points to which it is connected. When it has a infinite resistance, no current or no would pass through it, hence it would be able to measure the voltage reading accurately. A variable resistor or a rheostat controls current, or it is used as a potential divider to control voltages. Basically, a variable resistor, like I've said in my previous lecture as well, is a component whose resistance can be changed. What is a fuse? A fuse is a short piece of thin wire which overheats and melts to break the circuit if current is of more than its rated value. A fuse basically consists of a thin wire, and if a greater current flows through it, then it becomes heated up and it melts, breaking the circuit, protecting the components that are connected in that circuit. A fuse is connected always in series to protect the devices they are meant to protect. Resistance of a thermistor. What is a thermistor? This thing depends upon its temperature. The thermistor is short for thermally sensitive resistor. When the temperature rises, its resistance decreases. When the temperature drops, its resistance rises. An LDR is a special type of resistor which works upon light intensity. If the light is bright, the resistance drops. When the light is dim or low, the resistance increases. A light emitting diode or an LED allows the current to flow through it in only one direction while producing light. When the current passes through it, it shines brightly with only a small voltage across it. LEDs are usually used in circuits as an on or off indicator or simply to light things up. A series circuit. A series circuit has the same current through each circuit component but different voltage across each one of them. Because why different potential difference? Because every component takes some of the voltage for itself. In a series circuit, the flow of charges has only one path to follow. The flow of charge passed through each component in turn means one by one. Therefore, in a series circuit, every component has the same current but different potential difference. Adding a new component reduces the current flow throughout because of the added resistance of the new component. This is an example of a series circuit in which 3 lamps have been connected in series. Now, the current would remain the same through all 3 of them, but the voltage would be dropped. When the voltage, this is the, as you can see from the this is the symbol for a battery. Now the voltage would start coming out of this terminal and it would go across lamp C, lighting it. Some of the voltage would be used up, then it would go to lamp B, light it up. Some more voltage would be used up, then it would go to lamp A, lighting it up, expending more voltage, whereas the current, the amount of charge that flows around would remain the same. Different potential difference. Potential difference between 2 points in a circuit is caused by the energy dissipation. Energy is a scalar quantity, so it can be added to get the total energy. In a series circuit, the sum of potential difference across the sinks is equal to the sum of EMF across the source, the battery. Means whatever potential difference is being supplied by the battery, it is evenly distributed between all the components. In series circuit, the highest potential difference occurs across a component with the largest resistance. The potential difference between ends of any of pieces of connecting wire is effectively zero because there is no loss of potential energy. Means from this point to this point, since this is a straight wire, so potential difference does not drop, it remains the same. Circuits can be connected in parallel as well. In parallel circuits, the current is different throughout all the components, but the potential difference remains the same because the current now has different paths to choose from. Why the potential difference is same? Because different potential differences across the circuit components within the branch. Let's see it with an example. See, this is an example of a parallel circuit. Now the potential difference between this point and this point would be same no matter how many bulbs you place over here. As in series, the potential difference, all of them would be connected in series, so their potential difference. So the sum of the bulbs over here connected in series, their EMF would be equal to the EMF provided by the cell. Means the EMF between this point and this point would be same. Whereas the current now has over here two paths. Either some of the charges would go through here and the rest would go through here. So current would be divided. Instead of wiring components in series when they are connected in parallel, so they now have different paths to follow. Therefore, in a parallel circuit, the current from the source is the sum of currents in the separate branches of circuit. If one lamp is removed, the others still light up. If this lamp goes out, the other one would still light up because the current would simply stop flowing in this path and it would simply choose the other one. This is why most household lighting circuits are connected in parallel. So even if one of the components malfunctions, if a bulb burns out or a fan burns out, all the other household appliances still keep on working because every appliance is connecting through a parallel circuit. The largest current will pass through the branch with the smallest resistance. At a junction, the total current entering a junction is equal to the total current leaving the junction. That is the law of conservation of charge. Same potential difference. In a parallel circuit, two or more components are connected between 2 points of the circuit, like over here. The potential difference across a component is the difference between the 2 points and is equal to the potential difference of any other component connected in between. Hence, on the separate branches of a parallel circuit, the potential difference is same. Next we have resistors. Now, although we draw resistors like this, but resistors can also be drawn using this symbol. Now if you connect some resistors in series, then what happens that their total resistance adds up. Like between this point and this point, all these 4 resistors would have a combined resistance. Like for example, this was 10 ohm, this was also 10 ohm, this was 20 ohm, and this was 10 ohm. So from between this point and this point, the total resistance would become 50 ohms. You can calculate the effective or the total resistance of resistors in series by using the formula R, means total resistance equals to R1 plus R2 plus R3, so on, and Rn. Rn basically means whatever is the number of resistors connected in series. In a series connection, the R is always larger than the largest of the individual resistor because all of the resistances are added up. Resistors can be connected in parallel like this, And how do we calculate effective resistance or total resistance for this? We use the formula R equals to 1 upon R is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4, or as many resistors as you like. In case of parallel connection, the total resistance R is always less than the smallest of the resistors, the individual resistor in a circuit. Next, we have a component that is known as a variable potential divider or a potential divider or a potentiometer. It is a single component that consists of a huge coil of wire with a sliding contact. The sliding contact has the effect of separating this potentiometer into two parts, upper part and lower part, both of which have different resistances. If the slider is moved upwards, means it is moved over there, the resistance of the lower part will increase, and so the potential difference across it will also increase. If the slider is moved over there, that means the current entering from here or the voltage entering from here will have to pass through a larger length of wire, hence the resistance would be increased because length is directly proportional to resistance. We can also use two or more resistors as potential dividers. They are connected in series, and this is technically known as Kirchhoff's second law, but Kirchhoff's laws are not a part of O-level physics. They are a part of A-level physics, so don't really be concerned with the name. The potential difference across the power source is divided between them. Anyways, the point was when the resistors are connected in series, the EMF being provided by the source is divided between them. So potential dividers are circuits which produce an output voltage as a fraction of the input voltage. Because of the resistors, the output voltage is always lower than the input voltage. They are used to provide a variable potential difference. They are used to enable a specific potential difference to be chosen, means they are used when you want a specific output from the circuit, and or they are used to split the potential difference of a power source into two components or more components. This is what a potential divider circuit looks like. You have a power source, then you have two resistors, and a voltmeter is connected in parallel across the second resistor. Remember that in a potential divider circuit, the upper one is always R1 and the lower one is always R2, whereas you get the voltage out by taking one junction from over here and the other junction from there. You may or may not get a voltmeter every time in your circuit drawing. Even if there is no voltmeter, still this would be the connection for voltage out. See, the voltage in was 6 volt, now it has been lowered down to 3 volt. These are used widely in volume controls and sensory circuits using LDRs and thermistors. Usually what happens in volume controls or light controls circuits, instead of this R1 they put a variable resistor, and once you press on the knob, once you move the knob for volume on speakers etc., then what happens is the resistance of that LDR changes, hence the overall circuit resistance or circuit resistance ratio changes, and hence you get different output for the current that causes the volume to go up or go down. These circuits are based on the ratio of voltage between the two components, and you can calculate the formula that connects V in and V out together, which is a very important one from paper point of view, by the way. Is supposed to be this, so learn it by heart. V out equals to V in multiply by R2, means whatever is the value of R2 in ohms, divided by R1 plus R2, means the value of ohms for these two. Like if I have to apply this formula on this circuit, so I would get something like this. V out equals to V in, that is 6, multiply by R2, that is 200, divided by R1 plus R2 means 200 plus 200. So this would give me 1200 divided by 400, and that would give me 3 volts, which is our output. So we have basically discussed this. V in is applied to the top and bottom of the series. Now if you have to find the voltage across this resistor, then it would simply be the same as this one, because between this battery and this first resistor there is no other component. V out is measured across R2. The potential difference V across each resistor depends upon its resistance. The resistor with the largest resistance will have a greater potential difference because of V equals to IR, and if the resistance of one resistor is increased, it will get a greater share of potential difference, while the other one will get a smaller share. In such circuits, the ratio of voltages across the two resistors is given by V1 upon V2 equals to R1 upon R2. If you need to calculate current in any one of the resistors, simply use V equals to IR formula. Next we have something that is known as the input sensors. This is a new topic in the syllabus. There are two components which can be used as sensory devices. One is an LDR and the other one is a thermistor. So what is exactly is a light dependent resistor? An LDR is a semiconductor component whose resistance decreases as the intensity of light falling it increases. They can be used in circuits such as light operated intruder alarms, so that if some light falls onto it, its resistance would drop and it would allow current to flow through it, and there would be a buzzer or some alarm connected to it that would ring. If its resistance would drop, that means current would be able to pass through it and turn on whatever device is connected to it. It is drawn in the circuit like this, whereas in reality it looks something like this. Another sensory device is thermistor, a negative temperature coefficient thermistor. That is the full name for it. It is made up of a semiconductor material whose resistance decreases with increase in temperature. So if the heat or the temperature goes up, its resistance would drop, the current would pass through it, turning on whatever device is connected to it. It may be a fire alarm that would work on basis of increasing temperature, etc. This can be achieved by either heating the thermistor or running a current through it, because running a current through a semiconductor also produces heat. This can be used in temperature controlled circuits, for example switching on water sprinklers when heat is detected, etc. The actual component looks something like this, whereas in circuit diagram it is drawn like this. Then we have relays. These are electrically operated switches that open and close the circuit by receiving an electrical signal. In this way, small current can be used to operate open or close circuits with larger currents. This is a small battery of 9 volt, and here is the switch. Once you turn on the switch, then what happens? This is a relay. When current passes through this coil, it turns into an electromagnet, and this switch comes over here due to electromagnetic attraction, completing the circuit. And this large lamp that is of 5 volt and that is run by this power supply of 230 volt is safely switched on. So a relay is basically a electromagnet that is used to operate one circuit by a very small safe circuit. Next we have an LED or light emitting diode. It is a semiconductor that emits light when an electric current flows through it. This is what it looks like, and this is how it's drawn in a circuit diagram. before the arrow it is the positive terminal, and after the arrow it is supposed to be the negative terminal. You are supposed to connect the positive terminal of battery over here and the negative over here. Next we have semiconductor diodes, which is made up of semiconducting materials such as silicon or germanium. It is a two-terminal electronic component that only allows current to pass through it in one direction. And what is that specific direction? That the arrow of the diode symbol should be facing in the direction of the flow of the current. And once the diode is connected in that direction, it is known to be forward biased. Whereas if it is connected in the other direction, it is known as reverse biased. When the external voltage across semiconductor diode is applied in a way that the arrow symbol is in the direction of the current, it is said to be forward biased. A diode only allows current to pass through it if it is connected in forward biased. Means if the current is going in this direction, it would allow the current to pass through it, whereas if current is trying to come into from this direction, means if you reverse the poles, it will not allow the current to pass through. It is useful as a rectifier for changing alternating current to direct current. This is what a diode looks like. This white band represents the arrow symbol or the direction of the current or the negative terminal, whereas in circuit symbol it is drawn like this as an arrowhead, sort of an arrowhead. Example questions. The diagram shows three 6 ohm resistors connected to give various total resistances. What is the difference between the smallest and the largest total resistance? Now they are connected in series, so this would give the largest total resistance, and when they are connected, all of them are connected in parallel, this would give the smallest possible resistance. Now let's calculate what's the difference between them. You connect 3 resistors in parallel of 6 ohm each, you get 6 plus 6 plus 6, 18 ohms. And when you connect them in parallel, the formula is 1 upon R equals to 1 upon R1, that is 6, plus 1 upon 6 plus 1 upon 6. So 1 divided by R would be, this would be something like 0.33 if I am not wrong. .5. So 1 upon R comes out to be 0.5. Let's just cross multiply it, bring R above, so R would become 1 divided by 0.5. So R would come out to be 2 ohms. Now the smallest is 2 ohms and the largest is 18 ohms. So what would be the difference between them? The difference would be of 2 ohms. Let's check our answer. Yes, the answer is D, 16 ohms, because 18, the largest, minus 2, smallest, is 16. Which symbol does not represent a power source? This is a power source, this is a battery, this is AC, this is also a battery, but this is a voltmeter. So the answer would be B. A thermistor and a light dependent resistor are connected in series. A potential difference of 6 volt is applied across them. So this is basically a potential divider circuit. This is a thermistor, this is an LDR. They both are resistors. Basically, do not be alarmed, they both are resistors. So the same formula such as this one would apply across them. These two can be any types of resistors, they do not have to be fixed resistors. The thermistor has a resistance of 6000 ohms in cold room and 1000 in warm room. The LDR has a resistance of 2000 ohm in dim light and 500 volt in 500 ohm in bright light. When is the PD across the LDR equal to 2 volt? Now we'll simply apply the formula that was V in multiplied by R2 divided by R1 plus R2. Now let's check our answers. In a cold room with bright light, cold room is supposed to be 6000 ohms and bright light is supposed to be 5000 ohms, and V in is 6 volts. R2 is supposed to be an LDR. Yeah, so 500 divided by 6000 plus 500, this would not give us 2 volt. This would be 3000 divided by 6500, we would not get 2 volts. So A cannot be our answer. In a cold room with dim light, let's check this one. 600 into cold room is supposed to be again 6000 divided by 2000 plus 600, 6000, 2000 for this and 6000 for this. Now this would become 36,000 and this would become 8,000. We would not, when we divide these two, we would not get 2, whereas so this cannot be our answer. In a warm room with bright light, in a warm room, 6 multiplied by warm room is supposed to be 6 into what is R2? R2 is LDR. Warm room is supposed to be 1000 divided by R1 with bright light, 500 for bright light plus R2 is 1000. Sorry, bright light is supposed to be 500. So 6 5 3000 divided by 1500 would give us 2. So that means C is supposed to be our right option or right answer. So that's it for today. I hope you have understood everything. If you have any problems, please do comment below and I'll make sure to respond to them. If you have understood everything, just give a thumbs up down below in the comments and share it with your friends. I'll see you guys in the next lecture. Take care. Allah Hafiz.